What is a Telegram bot? A Telegram bot is a third-party application that runs inside Telegram. You can interact with bots by sending them messages, commands, and inline requests. They can do anything: teach, play, search, broadcast, remind, connect, integrate with other services, or even pass as a smart version of command line interfaces. In this code snippet, we are using the PyTelegram bot API library, imported here as Telebot. We first define our API key, which we got from the bot father on Telegram. Then we create an instance of Telebot with that API key. The @bot.messageHandler decorator is used to define a function that sends a welcome message whenever a user sends the /start or /help command. Finally, bot.polling is called to start the bot and keep it running, polling for new messages. Overview of the Telegram bot API. The Telegram bot API allows developers to build bots that interact with users on the Telegram platform. A bot can send messages, manage group chats, and respond to user commands. To use the Telegram bot API with Python, we typically use the Python Telegram bot library, which provides a convenient interface for the API. This snippet demonstrates the basic setup for a Telegram bot using the Python Telegram bot library. First, we import updata from telegram.ext, which is a class that continuously fetches new updates from Telegram and delivers them to the application. We initialize updata with the bot's token. The dispatcher variable is then used to add various handlers for commands, messages, and other events. The start polling method is called to start the process of polling, and idle is used to keep the bot running until it is stopped or receives an interrupt signal. Introduction to Python programming. To start programming with Python, you need to set up a Python development environment on your computer. This involves installing Python and a code editor or integrated development environment (IDE), and ensuring that you can run Python code on your system. After setting up your Python development environment, you can write Python code such as the Hello World program above. In this code, print is a built-in Python function that outputs the specified message to the console. When you run the program, it displays Hello World in the terminal. Setting up a Python development environment. Before creating a Telegram bot in Python, you need to set up a Python development environment. This involves installing Python on your system and choosing an IDE or text editor for writing your code. Additionally, you may want to install a virtual environment tool like virtualenv to manage project-specific dependencies without affecting your global Python setup. The code above demonstrates the setup process. First, you install the virtualenv tool with pip, which is the Python package installer. Next, you create a new virtual environment named mybot.env. After creating the virtual environment, you activate it. This step is different depending on your system. Source is for Unix-like systems. On Windows, you'd use mybot.env scripts activate. Finally, you install the Python Telegram bot library within the activated environment using pip. This library provides tools to interact with the Telegram bot API using Python virtual environments. Before we dive into creating a Telegram bot, it is essential to understand the concept of Python virtual environments. A virtual environment is an isolated space on your computer where you can install Python packages without affecting other projects or the system's Python. It helps maintain project dependencies separate and avoids version conflicts. The first command, python mvenv.bot.env, creates a new virtual environment named bot.env. The second command, source.bot.env activate, is for Unix-based systems and activates the virtual environment, allowing you to use Python and pip to install packages that are local to this environment. On Windows, you use bot.env scripts activate instead. Once activated, any package you install using pip will be placed in this virtual environment, separate from the global Python installation. Installing Python and pip. Before you start developing your Telegram bot, you need to have Python installed on your development machine. Python is the programming language we'll be using to write our bot. Python installation differs slightly depending on your operating system: Windows, macOS, Linux. Generally, you would go to the Python website, download the latest version for your OS, and run the installer. Make sure to check the box Add Python to Path during installation on Windows to ensure that the Python executable is accessible from the command line. On macOS and Linux, Python is often pre-installed. You can check the installation by typing Python version or Python 3 version in your command line or terminal. Creating a Telegram bot with BotFather. To create a Telegram bot, first you need to communicate with BotFather, which is the bot to create bots on Telegram. This process will give you the API token you need to program your bot. Once you've started a chat with that BotFather, it will guide you through the bot creation process. Sending the /newbot command begins this process. BotFather will then ask you to choose a display name for your bot, which can be anything you like, and a username that must be unique and end in bot. After completing these steps, BotFather will provide you with a token. This token is like a password to control your new bot via the Telegram bot API. Retrieving the bot token. Before you can start coding your Telegram bot, you need to retrieve the bot token, which is a unique identifier that allows you to authenticate your requests to the Telegram bot API. This token is provided by BotFather, the official bot for creating and managing other bots on Telegram. The code line above illustrates how you would store your Telegram bot token in a variable named bot token within your Python script. Replace your bot token here with the actual token you received from BotFather. This token should be kept secure and not shared with others, as it grants full control over your bot. Understanding the Telegram bot API. The Telegram bot API is an HTTP-based interface created for developers that want to build bots for Telegram. To use it, you need to create a bot with BotFather on Telegram to receive an API token. This token is like a password that allows your program to interact with the Telegram API to send and receive messages, as well as other bot functionalities. In the provided code, we're using Python's requests module to send an HTTP GET request to the Telegram bot API getMe method, which is used to test your bot's auth token and get basic information about your bot. Replace your bot token with the actual token you received from BotFather. The response.json call will pass the JSON response from the Telegram API into a Python dictionary, which includes details about your bot such as its username and ID. Introduction to using a code editor, e.g. VS Code, PyCharm. A code editor is a tool where you can write and edit your source code. For Python and developing Telegram bots, popular editors include Visual Studio Code, VS Code, and PyCharm. VS Code is lightweight and customizable, while PyCharm is a more feature-rich integrated development environment, IDE, specifically for Python. In this introduction, we'll set up a simple Python environment in VS Code. The code snippet demonstrates the use of the print function in Python, which outputs text to the console. In a code editor like VS Code, you'd type this code into a new file with a .py extension. After saving the file, you can run the Python script either by using the integrated terminal in the code editor or the editor's built-in run function, which will produce the output "Hello Telegram bot" in the console. This basic operation is used first in verifying that your development environment is correctly set up and that you can execute Python code, which is essential for building a Telegram bot. Installing the Python Telegram bot library. Before you can start writing a bot using the Python Telegram bot library, you need to install the package. This can be done using pip, which is the package installer for Python. Make sure you have pip installed and working. It's a good practice to use a virtual environment for your Python projects to avoid conflicts between package versions. The command pip install Python Telegram bot -upgrade is used to install the latest version of the Python Telegram bot library and upgrade it if it's already installed. The NAS upgrade flag tells pip to update any existing version to the latest release. It's generally recommended to use the latest stable version to take advantage of recent fixes and enhancements. After executing this command, the library and its dependencies will be downloaded and installed, allowing you to start writing your Telegram bot. Creating a basic bot with Python Telegram bot. To create a basic Telegram bot using the Python Telegram bot library, you first need to get a bot token from BotFather on Telegram. After that, you can set up a Python script where you import the necessary components from the library, initialize the bot with your token, define a command handler, and start polling the bot for updates. The provided Python script starts with importing the updater and command handler from the telegram.xt module. The function start replies with a hello message whenever the /start command is issued. The token variable holds your unique bot token received from botfather. An updater object is initialized with the token and starts listening for incoming updates. A dispatcher, DP, is created to register handlers which define how the bot responds to commands. A command handler for the /start command is linked with the start function. Finally, start polling begins the polling process to fetch new updates, and updater keeps the bot running. Running a simple echo bot. An echo bot is a simple program that reads a message from a user and sends the same message back. This is often one of the first bot types created for learning purposes. To achieve this, we will use the Python Telegram bot library, which provides a convenient way to interact with the Telegram bot API. Our bot will use webhook or polling to receive updates from Telegram and process them accordingly. The code starts with importing necessary components from the telegram.xt module, which provides classes for handling different types of updates. The echo function defines the behavior of our bot when it receives a text message. It simply replies with the same text. The main function sets up the bot, starting by creating an updater object with the bot's token. The updater object is responsible for receiving the updates from Telegram. A dispatcher object is retrieved from the updater to register a handler for text messages, the message handler. This handler is configured to filter for text messages using filters.text and pass them to the echo function. Once the handler is created and registered with the dispatcher, the updater starts polling for updates. Finally, the updater.idle keeps the bot running until it is manually stopped to process messages continuously. Understanding the dispatcher, updater, and handlers. In the Python Telegram bot library, the updater object fetches new messages from Telegram and passes them to the dispatcher, which then dispatches them to the appropriate handlers. Handlers are used to define how different types of updates are to be managed and can be specific to messages, commands, or other update types. This code initializes an updater object with the Telegram bot token. The start function defines the behavior for the /start command, replying with a greeting message. A command handler is created to handle /start commands by calling the start function. The command handler is registered with the dispatcher, which is obtained from the updater. Finally, start polling begins checking for updates, and idle keeps the program running until termination. The dispatcher will ensure that whenever a /start command is received, the start the step function will be triggered. Writing your first command handler. In creating a Telegram bot using the Python Telegram bot library, command handlers are crucial. They define how your bot will respond to specific commands that users send. Commands in Telegram bots start with a /, such as /start or /help. Let's write a handler for the /start command, which is typically the first command a user sends to interact with a new bot. The code defines a function named start that takes two arguments, update and context. The update parameter is an object that represents the incoming update, and context provides additional information and capabilities. Inside the start function, update.messagedReplyText is called to send a message back to the user. A command handler object listens for the /start command and is linked to the start function. This handler is added to the bot's dispatcher, which routes incoming commands to their respective handlers. Finally, updater.start polling begins the bot's polling of Telegram servers for new messages, and updater.idle lets the bot run until interrupted, e.g. via Ctrl+C. Replace your token with your bot's actual HTTP API token. Understanding webhooks versus long polling. In the context of Telegram bots, both webhooks and long polling are methods used to receive updates, like messages or commands, from Telegram servers. Webhooks involve configuring a bot to listen for updates at a specific URL, your server. When an update occurs, Telegram sends an HTTP post request with the update's data to the URL. Long polling, on the other hand, requires a bot to periodically send HTTP GET requests to Telegram servers, asking for new updates. Unlike webhooks, long polling doesn't require a server with a public IP address or SSL certificate. In the code snippet, we configure a Telegram bot to use logging for debugging, and then we create an updater object passing in a bot token. For long polling, we simply call the start polling method on the updater object, initializing a loop that will check for updates. No additional server configuration is required. For webhooks, we initially comment out those lines. If active, start webhook would tell our bot to listen on all interfaces 0.00.0 on port 8443. The bot's setWebhook method registers our URL with Telegram. Our server is then responsible for receiving updates at the specified path. Note that using webhooks requires a server setup with SSL TLS to ensure secure communication. Setting up a local development server. Before deploying your Telegram bot, it's crucial to test it locally. For webhooks, your development server needs to be reachable via the internet. We'll use ngrok to expose our local server and Flask, a micro-web framework written in Python, to set up the server. In the provided code, we create a simple Flask server with a /webhook route to handle incoming webhook requests from Telegram. When a new update, message from a user, arrives, the webhook function is called, which retrieves the update's JSON data via request.getJSON. The server should respond with a 200 OK status to acknowledge receipt. Running this Flask app starts a local server that can now be exposed to the internet with a tool like ngrok to start receiving updates from Telegram. Using ngrok for local webhook testing. Testing webhooks locally can be challenging because Telegram requires the webhook URL to be a public one. ngrok is a tool that creates a secure tunnel to your local host, allowing you to expose a local server to the internet. This is very useful for testing your Telegram bot's webhook on your development machine without deploying it to a server. This code snippet creates a simple Flask server intended to be run on your local machine. Flask is a lightweight WSGI web application framework. You need to replace your bot token with your actual Telegram bot token. The Flask app is configured to receive post requests on the route that includes your bot token, process the requests as Telegram updates, and then call the Telegram bot to handle the updates. When ngrok is run, it will give you a public URL that you can set as your Telegram bot's webhook URL. With the ngrok tunnel in place, Telegram will send all updates to the public ngrok URL, which in turn will be received by your local Flask server for processing. Configuring webhooks for Telegram. When configuring a webhook for a Telegram bot, you provide a URL to Telegram servers so that Telegram can send updates to your bot whenever there is a new message or command. To set a webhook, you need a server with a valid SSL certificate. Telegram does not support unencrypted HTTP for webhooks, and a method to process incoming updates. This code defines a function setWebhook that takes two arguments, your bot's token, bot token, and the URL where you want Telegram to send updates, URL. Using Python's requests library, it sends a post request to the Telegram API setWebhook endpoint, attaching the desired URL in the data payload. If successful, Telegram will start sending updates to the specified URL. The function then returns the response from Telegram in JSON format, which can be used to verify that the webhook is set up correctly. Switching between long polling and webhooks. Telegram bots can receive updates via two ways, long polling and webhooks. Long polling requires the bot to request updates frequently, while webhooks allow updates to be sent to the bot as soon as they occur. Each method has its advantages, and switching between them can be necessary based on the usage context, server capabilities, and environment limitations. The given code snippet shows how to switch between long polling and webhooks in a Python Telegram bot using the Python Telegram bot library. Initially, we import the required classes and define the webhook URL. After initializing the updater with the bot token and defining a simple start command, we add a condition to choose between webhook and long polling methods. If useWebhook is true, start webhook is called with the necessary parameters to listen for updates. Otherwise, start polling is used to continuously request for updates. Updater.deal is called at the end to keep the bot running. Passing text messages and commands. In a Telegram bot, passing text messages and commands is vital for understanding user intentions and responding appropriately. We often use Python libraries like Python Telegram bot to detect and pass commands. Here we'll discuss how to pass both commands and regular text messages. Commands in Telegram are typically prefixed by /, and the bot should recognize these and take action accordingly. Text parsing involves interpreting the contents of the message for a non-command interaction. Our code starts with importing required classes from the Python Telegram bot library. We then create a command handler to parse and handle commands, in this case, a simple start command. We also create a message handler with a filter for text messages to handle all other non-command text. This gives the bot the ability to differentiate between different message types and respond appropriately, using filters to handle different message types. In Telegram bot development with Python, filters are used to determine which updates should be passed to a handler based on specific criteria. For example, filters can be applied to process only text messages, commands, or various content types like photos, audio, etc. Using the Python Telegram bot library, filters are applied by importing the filters class and using it when adding handlers to the dispatcher. The filters.text filter ensures that text handler is only called for text messages, while filters.photo limits photo handler to photo messages. Handlers are added to the dispatcher, which is responsible for dispatching various types of updates to the bot's callback functions based on the filters applied. When an update fulfills the specified filter's conditions, the corresponding handler is invoked to process that update. This code spawns a bot that will respond to text and photo messages by notifying the user of the message type they've sent. Custom filters. In the context of Telegram bots, filters are used to determine which updates a handler should process. By creating custom filters, we can fine-tune which messages or updates our bot acts upon, depending on our unique criteria. In this code example, custom filters defined by subclassing baseFilter from the Python Telegram bot library. The filter method is overridden to check if the message text contains the string SomeCriteria. A new instance of custom filter is created, named myCustomFilter. When adding a message handler, pass myCustomFilter as the filter, so the handler will only be called for messages that pass your custom criteria. Inline keyboard and callback queries. Inline keyboards are a powerful feature of Telegram bots, which allow you to add interactive buttons to your bot's messages. When a button is pressed, a callback query is sent to your bot, and you can handle it to update the message or respond in some way. This interactivity can greatly enhance the user experience. The code provided sets up a simple Telegram bot that utilizes inline keyboards and handles callback queries. The start command initiates a message with an inline keyboard with two options. When the user clicks a button, the button function handles the callback query, sends an acknowledgement with query.answer, and updates the message to show which option was selected using query.editMessageText. The updater object starts the bot, and the dispatcher routes incoming updates to the respective handlers. This interactive approach is vital for creating engaging and responsive Telegram bots. Editing messages and managing chat elements. In Telegram bots, you may want to edit messages that were already sent, instead of flooding a chat with corrections or updates. This is particularly useful for correcting mistakes, updating information, and managing interactive chat elements, like inline keyboards within a message. Telegram Bot API allows editing both text and media messages as well as inline keyboards. The provided code uses the editMessageText method of a bot object to edit the text of an existing message. The chat ID specifies the chat where the message exists. Message ID is the identifier of the original message that we want to edit, and text holds the new content that will replace the old message text. Remember to handle exceptions, as editing messages can fail if the message is too old or if the bot does not have appropriate permissions. Sending and receiving photos, audio, and video. To send photos using a Telegram bot in Python, you'll typically use the sendPhoto method of the telegram.bot class provided by the Python Telegram bot library. The method requires at least two arguments: chat ID. The chat ID specifies where to send the image, and the photo parameter can be a file ID, an URL, or a file-like object. In the given code snippet, we first import the bot class from the Telegram module. We then create an instance of bot using the provided token. The chat ID should be replaced with the actual ID of the chat where the photo will be sent. The photo URL is the URL to the image we want to send. Finally, send photo is called on the bot instance, passing in the chat ID and photo parameters. If you're sending a local file, replace photo URL with an open file object, like open path to image.jrb. File I/O in Python. File I/O, input-output in Python, involves opening a file, reading its contents, possibly modifying it, and then closing it. Here's how you can open a file, read from it, and close it safely using a context manager. In this example, we used the with statement to open a file named example.txt in read mode R. By using a context manager with, Python automatically closes the file for us when we're done with it, or if any exceptions occur. We read the entire contents using file.read and store the result in contents. After the block, we print the contents to the console. This code snippet assumes that example.txt exists and is in the same directory as the script. Handling file uploads and downloads with Telegram. In this section, we'll learn how to handle file uploads in a Telegram bot using Python. When a user sends a file to the bot, it could be an image, a video, a document, etc. Telegram servers provide a unique file ID for these files. We use Python Telegram bot libraries methods to retrieve the file and save it locally. This code snippet creates a Telegram bot that can save any document it receives. The save document function is a handler that gets executed when a user sends a document. With update.message.document, we get the file sent by the user. The download method is then used to save the file locally with the given desired file name. We register this handler for documents using message handler filters.document, save document. The bot starts polling for updates from Telegram with updater.startPolling and runs until the updater.deal command is issued. Using the Telegram API for advanced file handling. In advanced scenarios, you may want to handle files and media beyond simple sending and receiving. The Telegram API provides methods to get file paths, download files, and send large documents. To work with this, you'll need to understand file IDs, manage bot permissions, and perhaps interact with the file system. In this code snippet, we first import the requests module to make HTTP requests and bot from the Telegram package. We initialize our bot with the appropriate token. We use getFile with a file ID to obtain the file's meta information. Next, we construct the file URL using the bot token and file path. We use requests.get to fetch the file data from the Telegram server. If the request is successful, HTTP status code 200, we open a new file in binary write mode, WB, and write the content of the response to this file, effectively downloading it. Understanding the conversation handler. The conversation handler in Python Telegram bot is a feature that allows developers to manage complex conversation flows with users. It helps to maintain different states in a chat and provides a way to transition between them based on user input. Each state is associated with a handler that defines how to process user messages in that state. In the provided code, a simple conversation handler is set up. It defines 3 states: choosing, typing reply, and typing choice, using range 3 for easier reference. The entry points parameter specifies the initial handler that kicks off the conversation, which in this case is start handler, triggered by the /start command. The states parameter is a dictionary mapping each state to a list of associated handlers that deal with user input for that state. Finally, fallbacks are the handlers that are used to end the conversation or handle any unexpected input. The handler is then added to the dispatcher of an updater object, which starts polling for new messages. By using the conversation handler, transitions between different conversational states can be managed cleanly and efficiently. Creating multi-stage conversations. Multi-stage conversations in a Telegram bot involve a series of interactive message exchanges. With Python's Python Telegram bot library, we can use the conversation handler to manage different stages of a conversation, using states to represent each stage. The bot responds differently depending on the current state, allowing for complex user interactions. In the provided code, we import the necessary modules and define states first and second. The start function begins the conversation by replying to the user and returning the first state. The first response function is triggered by a message in the first state, responds, and updates the state to second, leading to the second response method, which ends the conversation. The conversation handler manages entry points, states, and fallbacks, orchestrating message handlers based on conversation state. Updater initializes the bot with a given token. Handlers are added to the dispatcher, with the bot starting to poll for user messages, enabling us to manage the flow of the multi-stage conversation. Maintaining state and context of chat. In a Telegram bot, maintaining the state and context of a chat is critical for performing actions that depend on the previous input from the user. This involves tracking the conversation flow and storing temporary data according to the user's progress. Python Telegram bot offers a feature called Conversation Handler, which helps in handling such requirements efficiently. In the code snippet provided, Conversation Handler is used to create a simple conversation with two states, choosing and typing reply, represented by constants that are integers. When a user sends the /start command, the start function is triggered, prompting the user, and the conversation moves to the choosing state. When the user replies, the received information function stores the received message in context.userdata, which is a dictionary used to maintain state, and moves the conversation to the typing reply state. Note that fallbacks are empty in this example, but usually you will have at least one handler here to manage unexpected inputs or termination of the conversation. Using a job queue for scheduled tasks. In the context of a Telegram bot, using a job queue allows you to schedule tasks to be executed at a later time or periodically. This feature is particularly useful for reminders, delayed actions, or regular updates. In the Python Telegram bot library, you can use the job queue class to manage such tasks. Firstly, an updater object is instantiated with the bot token, which starts the bot. The job queue is then obtained from the updater. A callback function, callback_minute, is defined, which specifies what will happen when the job is executed. In this case, it sends a message to a specified channel. The run_repeating method of the job queue schedules the callback_minute function to run every 60 seconds, with the first execution starting immediately, first = 0. The start_polling method is called to start the bot and the job queue. Persisting conversation states and user data. In complex Telegram bots, you often need to manage conversations with users that span multiple steps and handle user data. To maintain the state of the conversation even when the bot is restarted or stops working, we use persistence. Python Telegram bot provides pickle persistence or dict persistence for this purpose. Here we'll use pickle persistence to save conversation states and user data to a file. The code snippet initializes a pickle persistence instance, specifying the file name where the conversation state and user data will be stored. It binds this persistence instance to the updater, which is responsible for polling Telegram for new updates. When using myPersistence, the bot will save conversation states and user data to mybot conversation_data.pickle. On subsequent bot restarts, the updater reads from this file to restore the last known state. This approach ensures user experience isn't compromised and that the bot can pick up conversations where it left off. Making HTTP requests with Python. One of the fundamental operations when working with APIs is making HTTP requests. Python provides several libraries to make HTTP requests, but one of the most common and user-friendly is requests. The requests library allows you to send HTTP requests using Python, handling tasks such as sending the correct headers, form data, JSON content, and more. Below is a basic example of how to use the requests library to make a GET request, which is often used to retrieve data from a specified resource. In this code block, we start by importing the requests library, which must be installed prior to use, using pip install requests. We then use requests.get https api.example.com/data to perform an HTTP GET request to the URL provided. The response from the server is stored in the variable response. We print the HTTP status code of the response, which indicates whether the request was successful, e.g. 200 for success. Finally, assuming the response contains JSON data, response.json is called to pass the JSON data into a native Python dictionary, which we print out. It's important to handle potential exceptions that may occur during the request, such as network issues or invalid responses. Integrating RESTful APIs with your bot. Integrating a RESTful API with a Telegram bot can enhance its capabilities by allowing it to fetch or send data to third-party services. One common Python library used for making HTTP requests is requests. In this example, we'll see how to interact with a simple RESTful API to get a random fact and send it to a user when they interact with the bot. In the given code, we import the requests library and Telegram bot handlers. The getFact function makes an HTTP GET request to a URL that returns a random dog fact in JSON format. We use response.json to pass the JSON response and extract the fact. Then, the update.message.reply text function sends this fact back to the user. We add this getFact function to a command handler, which is triggered when the command's fact is sent to the Telegram bot. The bot is started and set to idle, waiting for incoming updates. Error handling and logging. Error handling is a critical aspect of software development. In the context of a Telegram bot, it ensures the application can gracefully handle unexpected situations. Logging is equally important for debugging and keeping track of the bot's state and behaviors over time. By properly implementing error handling and logging, developers can quickly identify and fix issues, which leads to a more robust and reliable bot. In the provided code snippet, we've set up basic logging for a Telegram bot using Python's logging module. The basic config function is used to configure the logging level and format, ensuring that timestamp, module name, log level, and the message are included in each log entry. The logger object then helps us log messages throughout the bot's codebase. The error function is defined as an error handler, which logs warning messages if an update causes an error. It uses the warning method of the logger to include the update and the error context in the log message. Finally, this error handler is added to the dispatcher of the updater object, ensuring that any uncaught errors will be processed by this error handling function. Using environment variables for configuration. Environment variables are used to manage configuration settings outside of your application's codebase, reducing the risk of exposing sensitive information, such as API keys, bot tokens, or database passwords. They provide a level of abstraction that can be essential for maintaining security and flexibility, especially important in diverse environments like development, testing, and production. In this Python code snippet, we use the built-in OS module to load environment variables. The os.getEnv function retrieves the value of an environment variable, here accessing Telegram token and database URL. If the environment variables are not set, os.getEnv will return none. It is crucial to set these variables in your environment before your application starts. This practice keeps sensitive information out of the source code, which can be particularly important when sharing code through version control systems like Git. Securing sensitive information. When integrating with third-party services and APIs, it's essential to secure sensitive information like API keys, tokens, and passwords. Exposing such details in your code can lead to vulnerabilities and unauthorized access. It's a good practice to use environment variables for this purpose, as they separate the sensitive information from your codebase and can be managed independently based on the environment, development, staging, production. Python's OS module can be used to access environment variables. In the given code snippet, we're importing the OS module, which is a part of Python's standard library. We use os.getEnv to retrieve the value of an environment variable named Telegram token. This token is then stored in a variable for use throughout your application. If the environment variable is not set, os.getEnv will return none. It's recommended to handle the case where Telegram token is not found to prevent the bot from failing due to a missing token, typically by raising an appropriate exception or providing a clear error message. Understanding deployment options for bots. When deploying your Telegram bot, you have multiple options. It can be as simple as running it on your own computer, or as complex as setting it up on a cloud server to ensure it stays online and responsive 24/7. We will explore deploying a Python-based Telegram bot to a cloud service provider. Deployment is a crucial phase where your bot becomes accessible to users. Common deployment platforms include cloud services like Heroku, AWS Lambda, Google Cloud, etc. These platforms offer various benefits such as scalability, reliability, and sometimes free tiers for small-scale bots. For large-scale operations, consider using container orchestration services like Kubernetes. Remember to keep in mind factors like traffic, bot complexity, and budget when choosing where to deploy. You may also need to set up webhooks if you want your bot to be responsive to updates in real time. Consider using environment variables to keep sensitive information, such as your bot tokens, secure. Deploying a bot to a cloud service, e.g. Heroku, AWS, GCP. Heroku is a cloud platform that offers simple scaling and deployment. Deploying your Telegram bot to Heroku involves creating a proc file, setting up requirements.txt for dependencies, and pushing your code to Heroku using Git. We'll assume you have created a Heroku account, installed the Heroku CLI, and initialized your bot's code in a Git repository. The proc file tells Heroku how to run your application. It specifies a process type, web in this case, and the command to launch your bot, pythonbot.py. Upon deployment, Heroku reads this file and starts a dyno, which is a lightweight Linux container that runs the specified command. You also need to ensure that all dependencies are listed in requirements.txt, and your code is committed to the Git repository before pushing to Heroku. Using Docker containers for deployment. Docker is a platform for developers and sysadmins to develop, deploy, and run applications with containers. The use of Docker containers to deploy Telegram bots allows for consistent environments, ease of scaling and distribution, and isolation from the host system. To begin, you first need to define a Docker file that specifies the environment, dependencies, and the entry point for the bot. The Docker file starts by selecting a base image with Python 3.9 installed, Python 3.9-slim. It then sets the working directory to /app. The requirements.txt file, which lists the Python dependencies, is copied into the container and installed using pip. Then the rest of the bot's source code is copied into the container. Finally, the command to start the bot, pythonbot.py, is specified as the container's entry point. Once the Docker file is created, you can build and run your bot as a Docker container, ensuring it will work in a consistent environment regardless of where it's deployed. Logging and monitoring bot activity. Logging is crucial for monitoring your bot's activity and debugging issues that arise. Python's built-in logging module allows us to track events when our bot runs. This enables us to see real-time activity, understand user interactions, and keep records of the bot's operation. Configuring proper logging will help in monitoring the bot's health and performance. This code snippet initializes logging with an info level, which means it will capture all the events that are of the info level or higher in terms of severity, e.g., warning, error, and critical. We create a logger object for our module, and we use logger.info to record general information about the bot's activity, and logger.error to log exceptions and error messages. The xcinfo equals true argument includes the traceback information in the log, which is helpful for debugging. Scaling bots to handle large numbers of users. To ensure that your Telegram bot can handle a large number of users, you may need to use webhooks and implement load balancing with a web server like nginx. A webhook is a way for an app to provide other applications with real-time information. In the context of Telegram bots, using webhooks means your bot will only get updates when there are new messages, which is more efficient than continuously polling the server. Additionally, a load balancer like nginx can distribute incoming bot traffic across multiple instances of your bot running on different server processes or machines. In the given nginx configuration snippet, we define an upstream block called bot backend that consists of multiple server lines. Each line represents an instance of the Telegram bot running on different ports of the local host. Although in this example, the instances are running on the same machine, they could also be distributed across multiple machines. The server block sets up a standard HTTP server listening on port 80 with a special location block configured to pass requests for your bot, identified by your bot token in the URL, to the load-balanced bot backend. This ensures that incoming requests are evenly distributed amongst the available bot instances, improving the bot's ability to scale and handle more users. Writing unit tests for your bot code. Unit tests are crucial for ensuring that individual parts of your bot function correctly. They allow you to systematically check the behavior of your code against expected outcomes, providing a safety net against future changes that might introduce errors. For a Telegram bot, you might test command handlers, message processing, and interaction with external services. In this example code snippet, we're using Python's built-in unit test framework to write a simple test case for a hypothetical function process command from the bot. The Testbot class inherits from unittest.testCase, which is a standard way to organize tests. Within the class, the test process command method tests the response of the process command function when a /start command is issued. We use assert equal to ensure the output matches the expected response. Welcome to our bot. To run the test, we check if the script is the main program being executed, and then call unittest.main, which provides a command line interface to the test script. Mocking Telegram API calls for testing. In testing Telegram bots, it's good practice to avoid calls to the actual Telegram API. This ensures tests are fast, reliable, and do not have external dependencies. We achieve this through mocking, where we replace parts of our application with mock objects and define how they should behave. This is done to simulate the interaction with the Telegram API. In this snippet, unitest.mock.patch is used to replace the sendMessage method of the telegram.bot class with a mock object. We specify the return value of the mock to be true to simulate a successful API call. Within the with block, when our bot code calls sendMessage, it actually invokes the mock instead of Telegram's API. Finally, assert called once with is used to ensure that sendMessage was called exactly once with the expected arguments. This approach allows us to test the logic of our bot without actually sending a message through Telegram. Code quality and linting. Code quality is crucial for maintaining and scaling codebases. It impacts readability, maintainability, and functionality. To ensure high code quality, developers use tools called linters. Linters analyze source code to flag programming errors, bugs, stylistic errors, and suspicious constructs. For Python, PEP8 provides styling guidelines, and tools like Flake8 or PyLint help enforce them. In this example, we will use Flake8 to lint a Python file. The code snippet shows how to install Flake8 using pip, Python's package installer. After the installation, you can run Flake8 on your Python file, in this case bot.py, which hypothetically contains your Telegram bot's code. Flake8 will analyze the file and print out any issues it finds, such as lines that are too long, unused imports, or code that doesn't adhere to PEP8 standards. Addressing these issues leads to cleaner, more professional, and more maintainable code. Documenting your bot project. Proper documentation is crucial for maintaining, scaling, and facilitating collaboration in a bot project. It helps to understand the design, setup, and functionality of the bot. The given code block provides a template for documenting a Telegram bot project. It starts with a doc string that explains what the bot does, the requirements, installation process, and how to use the bot. For a more comprehensive documentation, you'd include descriptions of command handlers, error handling, and configuration. This metadata serves as both a guide for users and a reference for developers. Remember, the actual implementation code begins after the doc string with proper imports and bot initialization. Completing thorough documentation is an essential part of best practices in development. Applying best practices in Python project structure. When building a Telegram bot in Python, organizing your project with best practices helps maintain readability and scalability. It also aids in understanding the flow of the program and in debugging. In this structure, bot.py contains bot initialization and core functionalities such as command or message handlers. Config.py covers configurations like API tokens or database credentials. The utils directory has additional modules, helpers.py for auxiliary functions, and keyboards.py for creating custom reply keyboards. Main.py is the entry point, initializing the bot and starting the polling. This structure ensures that separation of concerns is respected and functionalities are modular for easy testing and maintenance. Localization and internationalization. Localization, L10N, and internationalization, IN, are processes that ensure a Telegram bot can operate and communicate in multiple languages, making it accessible to a wider audience. Internationalization is the process of designing a software application so that it can potentially be adapted to various languages and regions. Localization is adapting the application for a specific region or language by translating text and adding locale-specific components. The provided code snippet demonstrates a basic way to localize a Telegram bot greeting based on the user's language. The Babel library is used to detect and parse the user's language. When the user starts a chat with the Telegram bot, the start function is triggered. It extracts the user's language code from update.effectiveuser.languagecode, then creates a locale object for that language. Lastly, it sends a greeting in the user's language by getting the display name of the locale and appending it to the greeting message. This is a simplistic approach, but serves as a starting point for implementing localization in a bot. Inline bots and inline queries. Inline bots allow Telegram users to interact with your bot directly within the context of any chat without sending messages to the bot. Users type the bot's username, followed by a query in the message input field of any chat. The bot then can respond with a list of suggestions that can be inserted directly into the chat. This feature is enabled by handling inline queries in your bot's code. In the provided code, we import necessary objects from the Telegram library and define a function inline query that handles inline queries. When a user enters an inline query with your bot's username, the inline query function is called. Inside, we retrieve the query text from update.inlinequery.query. We then create a list of inline query result article objects with unique IDs, titles, and the message contents that should be sent when selected. These results are sent back to Telegram with context.bot.answer inline query. After defining the handler function, we initialize an updater with your bot's token, attach the inline query handler to the dispatcher, and start the bot. When the user selects a result, the respective content is sent to the chat. Creating custom keyboards. Custom keyboards are a powerful feature in Telegram bots that allow you to provide a more interactive experience for users. They are effectively specialized buttons that appear in the user's chat interface and can be fully customized. You can specify the text on each button, and each button press sends a message back to your bot. This feature enhances user engagement by making the interaction with the bot smoother and more intuitive. In the code, reply keyboard markup is used to create a custom keyboard. The keyboard variable is a list of lists, where each sublist represents a row of buttons, and each element is the text of a button. The resize keyboard parameter ensures that the keyboard fits the screen size, and one-time keyboard makes the keyboard disappear after one use. The reply text method sends a message to the user along with the custom keyboard. When the user taps a button, the text of the button is sent back to your bot as a regular message. Chatbots with natural language processing, NLP. Natural language processing, NLP, is a field of artificial intelligence that gives machines the ability to read, understand, and derive meaning from human languages. NLP is crucial for creating chatbots that can interpret and respond to user inputs more naturally. In this example, we'll integrate a simple NLP library with a Telegram bot to process and understand user messages. In the provided code, we're integrating NLP into our Telegram bot by using the NLTK library, which already has some basic natural language utilities. The bot is programmed to respond to users' messages based on predefined patterns. Each pattern has a regex pattern that the chat class uses to match user inputs and generate responses. Whenever a user sends a text message, the respond function is triggered. It passes the user's input to the chat instance to get an appropriate response. The message handler is set up to handle all text messages that are not commands and to execute the respond function accordingly. Lastly, we start polling for updates from the bot and enter an idle state, allowing the bot to run indefinitely until it's terminated. Leveraging AI and ML APIs for intelligent bots. To create bots that can understand natural language, generate human-like responses, or carry out complex tasks, we can integrate AI and ML APIs. These APIs, offered by various AI service providers like Google, IBM, or Microsoft, enable us to add features like language processing, sentiment analysis, and image recognition to our bots without being experts in these domains. The code provided is an example of how to integrate a generic AI API with a Telegram bot using Python's telegram.xt module. Firstly, the bot's updater and dispatcher are set up with the bot's API token. The AI message handler function is defined to handle incoming user messages. Within this function, user messages are sent to the AI API endpoint, along with the necessary authentication header. The JSON response from the AI service is then passed, and the relevant part of the response, message, is sent back to the user as a reply. This demonstrates a simple way to make a Telegram bot interact with an AI service API to enhance its capabilities. Project planning and requirement analysis. Before we dive into coding, it's essential to understand the project's scope and what our Telegram bot is intended to do. This stage involves determining the bot's functionality, the commands it will respond to, the data it might need to handle, and any integrations with external services or APIs. In project planning, we outline the goals and scope of the bot. For a basic bot, this could mean setting up commands for providing information, user interactions, or both. Requirement analysis helps list out specific features such as automated responses, content delivery, or data retrieval from external sources. This might not involve actual code, but it forms the blueprint that will guide the development of the bot. No code is written at this stage, as it is a conceptual and analytical phase of the project. Developing a feature roadmap. Before you jump into coding a Telegram bot, it's essential to plan a feature roadmap. This helps you prioritize which features to develop and organize your development approach. A roadmap is a high-level overview of the functionality your bot will offer over time. A feature roadmap does not necessarily involve code, but rather it's a strategic document or plan. For the Telegram bot, list down the features you want to include based on user needs, expected interactions, and the value each feature will add. For example, features might include processing commands, responding to keywords, handling inline queries, sending notifications, event scheduling, or integrating with APIs. By laying out these features, you can assess their complexity and interdependencies, allowing you to plot a timeline for development and release. Implementing advanced bot features. To implement advanced features, we'll use message handlers and filters to differentiate between various types of content the bot can receive. The message handler class and various filters provided by the Python Telegram bot library make it easy to define complex behavior. The provided code shows the usage of message handler with a combination of filters. In this case, filters.text ensures that the handler works only with text messages, while filters.command excludes messages that start with a slash, which are usually commands. Whenever a non-command text message is sent to the bot, the echo function is called, and it simply replies with the same text. Note that you need to set up the dispatcher and start polling for this code to function. This is usually part of the main function. Interacting with users and processing feedback. Command handlers allow the bot to recognize and respond to specific commands sent by users. Often these commands begin with slash, such as /start or /help. Handlers are added to the dispatcher, which will call a specified callback function when the command is received. The code snippet defines a start callback function that sends a welcome to the bot message in response to a /start command. The main function sets up the command handler to listen for the /start command and call the start function when the command is issued. Project documentation and user guide. Documentation is crucial for the understanding, usage, and maintenance of any software, including Telegram bots. It usually explains the purpose of the project, how to set it up, and how to use its features. This part doesn't provide a code snippet since it's a conceptual description. Good documentation typically includes an introduction to the project, the technologies used, installation steps, configuration procedures, usage examples, and instructions for contributing. In the case of a Telegram bot, documentation should pay special attention to how the bot is constructed, how to run it, what its commands are, and where to get support. Finalizing and testing the bot's functionality. The main function is the entry point of your Python program. Here, you'll tie together the functions you've created for your bot and start the bot's polling service to continuously check for new updates from Telegram. This code sets up logging to help you debug your bot. It then creates an updater object with the bot token, which is responsible for receiving the updates from Telegram. A dispatcher is obtained from the updater to register the command and message handlers you've defined earlier. Finally, start polling is called to start the bot, and updater.idle runs the bot until it is stopped manually.